Hello everybody and welcome back to Advanced Maths. Today we're looking at SOHCAHTOA and Pythagoras problems. These are exam style questions relating to Pythagoras theorem and SOHCAHTOA, so before we begin you must know your Pythagoras and SOHCAHTOA really well. Example 1, we're going to try and find the angle marked x in this diagram. And you can see it's two triangles stuck together. They are both right angled triangles. So that is a big hint that we're going to need Pythagoras or SOHCAHTOA for these, because if it's right angled triangles, it's Pythagoras or SOHCAHTOA normally. Well, here we have a triangle on the top, and we are given more information about the triangle on the top. So we'll start with this one, and this is connected to the triangle on the bottom by the middle line. And so if you find out the length of that middle line, that helps us find out some information about the triangle on the bottom. So we'll start with Pythagoras here because it's got two sides labelled and we want to find the third side. So we'll use Pythagoras and we'll substitute a, b and c into this formula. B is 3.5 and c is 11. We get a squared plus 3.5 squared equals 11 squared. We take 3.5 squared off both sides. And then we get rid of the a squared, we get rid of the squaring that by square rooting. We get a is the square root of 11 squared minus 3.5 squared, which you can type into your calculator, and you get 10.428 ... And that is the missing length in the middle. Now when you get this on your calculator, do not erase it. Do not press any button on your calculator because you want to save that number in its full detail, not rounded. So you're going to leave it saved as the answer to type into your next formula. Now we're interested in the triangle here, this green triangle. And here we're trying to find a missing angle, the angle x. And here we've got the opposite and adjacent, so we're going to use tan. So you're going to cover up tan, and we give an opposite over adjacent. Tan of the angle is opposite over adjacent. Substitute those numbers in, and then we do inverse tan to find the angle. So inverse tan of 10.428 over 5 is the angle x, and that gives us 6.438 or 64.4 degrees. 64.4 degrees is the final answer, and we have solved the problem. Now example 2, a man is holding a kite 0.8 meters above the ground. The string of the kite is tight and rests at an angle of 30 degrees above the horizontal. The kite string is 9 meters long. How high is the kite? Okay, so to understand what's going on here, we need to draw a diagram. So we'll draw the man standing on the ground with a kite string, and the kite string is straight because it's tight. He's holding it above the horizontal, and it is 0.8 meters above the ground. The kite string is 30 degrees above the horizontal. Now we're drawing a dotted line for the horizontal, which is just a horizontal line, a flat line, parallel to the ground. And we're trying to find the height of the kite. We have drawn this diagram now, and you should see a right angled triangle popping out of this diagram. We're trying to find the angle x, this length x here, and we'll add that to 0.8 to find the full height of the kite. And this is indeed a right angled triangle here. We're given the height is 9 meters, and the opposite is what we want to find. So we'll use sine, and we'll cover up the op. The op will be given by sine of the angle times the hypotenuse. And we substitute the numbers in. Sine of 30 times 9 is 4.5 meters. So between the horizontal and the kite is 4.5 meters. But we also need the 0.8 to find the full height of the kite. So we add those two together. 4.5 plus 0.8 is 5.3. And so the kite is 5.3 meters above the ground. Okay. And that is the final answer, of course. Our final problem is example 3. The area of this triangle is 150 centimeters squared. What is the size of angle theta? And just notice it is an isosceles triangle because it has two dashes on two sides, and that shows that those two sides are equal lengths. So it is indeed isosceles. The area of a triangle is given by the base times the height divided by 2. The area is 150 centimeters squared, the base is 10, and so we can find the height by solving this equation. We got 150 equals 10 times height divided by 2. That's the same as 150 equals 5h, because the 10 and divide by 2 becomes 5. We divide by 5, and we get the height is 30 centimeters. So you can substitute that into the original drawing. And so we have a right angle triangle now because the height is perpendicular, it's at right angles to the base. So just focusing on this triangle here, we've got the adjacent is 5 and the opposite is 30. We'll use tan again for opposite and adjacent. We cover up tan and we give an opposite over adjacent. Substituting those numbers in, and we take the inverse of tan, or tan minus 1, and we get 80.537 etc. degrees, which is 80.5 degrees. And so the final angle is 80.5 degrees, and we have the final answer. Okay. Now that is all the examples for today's video. You can pause the video now and try this yourself. There are 3 questions on the board on the screen for you to try. So pause the video. This will take you about 10 to 15 minutes to do them all, and see if you can solve these yourself. When you've done it and when you've got answers for all 3 questions, you can press play and I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the comments below. Thanks for watching this week's video from Advanced Maths. Remember to like and subscribe so you don't miss any future videos. We're covering GCSE, A-Level and IB Maths, and new videos are coming every week. You can also check out advancedmaths.com for more free revision resources. Thanks for watching and good luck in your exams.